I will present the contribution grouping representative points in Ahp-Fuzzysort with agglomerative hierarchical clustering. So this contribution has been developed in the University of Jaén by my group, and I will introduce today this presentation in which I will...
the background itu kan?
Sorry?
Yeah,
so I will try. Okay. So I will try to present very briefly some concepts about the multi-criteria decision sorting analysis. Then I will very briefly review Ahp-Sort 1 and Sort 2 with the Fuzzysort process. And then I will introduce the grouping of representative points with agglomerative hierarchical clustering in the process. And then I will try to show an illustrative example, and I will conclude the presentation. So when we are talking about multi-criteria decision sorting analysis, we should understand that multi-criteria decision analysis aims at supporting decision makers to make better, effective, and more consistent decisions. But sometimes this kind of decision has been applied to different kinds of problems, usually have been applied successfully to very different kinds of them. The most typical problematics in which multi-criteria decision analysis has been applied have been making a choice, determining a ranking, and sorting alternatives. So what is the main difference? So when we are going to make a choice, we have to choose the best alternative among the group of alternatives for the problem. When we develop a ranking, we are going to obtain a ranking of the alternatives in which can be incomparabilities, but we try to rank the alternatives from the best to the worst. But what happened in both cases? When we make a choice or when we determine a ranking, even the best alternative cannot be good enough for our alternatives, for our objectives. So with sorting, we try to sort the different alternatives into different classes, categories that are ordered from most to least preferred. So usually these categories are inherent to the problem or are defined properly by the decision makers. And in multi-criteria decision analysis sorting processes, we are not aiming at discovering new classes or the classes that could be the alternative sorting. These classes are already pre-existing in the problem. So the main point of the sorting processes is to carry out repetitive and automatic decisions over the alternatives for our problems. So there are different kinds of multi-criteria decision-making approaches, but in this case, we are going to focus on Ahp-Sort. For the Ahp-Sort have been defined two different methods and the station to the fuzzy sorting process. So I will try to review very briefly. So the main point in Ahp-Sort, as in other sorting problems, is to assign the alternative to a predefined group of categories. So these categories are defined in an ordinal way from the most to least preferred category. And all the categories are usually named by a nominal name. The most preferred, the second most preferred, we will see later on in an example. So the categories, as we will see just in the next slide, are defined by means of a profile. So how we are dealing with the Ahp-Sort? First of all, we will define the problem, like in Ahp, the goal, the criteria, and the alternatives. When we have defined the problem, we have to define the classes in which the alternatives will be categorized. And we have to order these classes and provide a nominal name, a label for each one, like excellent, good, medium, bad. So they are ordered from the most preferred to the less preferred. And then these categories should be defined by means of a profile. These profiles could be provided by means of a limiting profile or a central profile. A limiting profile is the least value that an alternative should have to be in that category. And a central profile is a typical value that an alternative presents in such a category. If we are dealing with limiting profiles, we need n-1 profiles for each criteria. And if we are dealing with central profiles, we need n central profiles for each criteria. So once we have defined the problem, we need to carry out the evaluation to make the final classification of the alternative. First of all, we will compute the weights for the criteria in a similar way to the Highspeed process. The fifth step is the main difference regarding the Highspeed. In Highspeed-sort, in the fifth step, we have to make pair-weight comparisons for each single alternative with each limiting or central profile of the different classes. And then from this comparison matrix, we will derive the local priority for each alternative and for each profile. So when we have the local priorities, we need to obtain the global priorities for the alternatives and for the profiles. And with these global values, we can make a classification of the alternatives into the different classes. We have to repeat the steps 5 to 8 for each alternative to be classified in the different classes. What happened? This process is quite easy to carry out and easy to understand, but it presents a problem regarding the idea of sorting that should be automatic. So here we need to make the step 5 for all the alternatives, even new alternatives. So the idea is to improve the Highspeed-sort into the Highspeed-sort 2 to avoid to make the comparison for each alternative. So the Highspeed-sort 2 try to define the range of the values that can be defined for a criteria, and then divide this context, this interval, into different representative points, and compute the priority for each point, and build a local priority function. And then for each alternative, we don't need to ask the priority. We can interpolate and obtain an approximate priority for each alternative. And then we can compute the global priority to make the final classification. In addition to the Highspeed-sort 2, we observe that the Highspeed-sort 2 have a problem with strict borders. That means that when we are classifying small differences for the global priorities can result in a different classification. So in order to avoid this problem, initially Isahp tried to deal with this problem by means of carry out a new tune process. But I was collaborating with Alessio to introduce the Fuzzysort process, in which we define the classes by means of fuzzy numbers, and then the classification can be done by using the membership function to these fuzzy numbers, and then we avoid this problem. So in both cases, dealing with Highspeed-sort 2 and Highspeed-Fuzzysort 2, we need to deal with the following problem. We have to define what are the representative points, and we have to make pairwise comparison of the representative points and profiles to obtain the priorities in this local priority function. So the initial proposal of Highspeed 2 is that you can divide the whole number of points and profiles into different clusters and join the cluster by means of a joining point. But there is not any indication about how many clusters or how many elements should be in each cluster. So from each cluster, we will carry out a pairwise comparison and we will obtain the priorities. And then we have to normalize the priorities to obtain this kind of local priority function. So to avoid problems with this kind of clustering process of the representative points, we have formalized the way to compute these subsets of points to make the comparison. And we propose the use of agglomerative hierarchical clustering, that is a simple clustering process that tries to group the different points into clusters according to their similarity. So the main point is that this process doesn't need to specify the number of clusters for the algorithm initially. So we can choose different number of clusters according to our needs, because in Highspeed it's not good to carry out pairwise comparisons for more than 9 elements, because the consistency could be not very good. So when we obtain 3 clusters, we get a cluster with many points, we can divide the cluster into a new one by using the Dendrogram. And then we can select the most suitable number of clusters. So in order to illustrate this idea, we are going to use an example we published in our paper about how the countries of the European Union are fulfilling the Sustainable Development Goal 8 of the Agenda 2030, that is decent work and economic growth. To measure the achievement of this goal for each country, we carry out these different criteria that we can see here. And we want to classify these countries into 4 different classes that are labeled by means of total, moderate, weak, and null. And we use a limiting profile to deal with these classes. So we can see in table 1 the different representative points for each criteria according to the numbers that presents each country for the previous criteria. And in addition, the different limiting profiles for the 4 different classes. In this case, we are working with limiting profiles, so we need 3 limiting profiles for 4 different classes. So starting for these reference points and limiting profiles points, we apply the HC agglomerative hierarchical process to obtain the different groups in which we are going to make the pairwise comparisons to obtain the local priority functions. Here is the example about the criteria 5, in which we obtain the first group with 3 points, the second with 4 points, and the third with 4 points. And that is the way that we deal with this classification by a formal method, not like in the initial proposal in which this classification or cluster process is not clearly defined and everyone can choose these points as they want. And in such a way, we can obtain this definition to obtain the classification for the different countries. And here we can see the final classification we obtain with the Ahp-Fuzzysort. So that is the main idea of this proposal, to formalize the way to cluster the representative points and the profiles for the classes in order to obtain the local priority functions in Highspeed-Fuzzysort. So that's all. Thank you very much. And if you have any questions, I will be happy to answer. Thank you very much.
Thank you.
Thank you, Professor, for the presentations. Sorry for being late. I was the chair, but due to some time issue, I missed the first part. Are there any questions to Professor Martinez? Professor, shall I ask a question? As far as I understand, is it possible to make a similar study by applying a fuzzy or a standard HP, finding some weights, and then making a clustering with these weights? Can we use such an approach like fuzzy clustering, for example? Is it possible, or is it rational?
What you mean is if we can try to simulate or compute automatically the prioritization of the different elements for new alternatives in Highspeed, we can apply the same process. So the idea in Highspeed-Sort is because the plan is to classify many alternatives across the time. So usually in Highspeed, we didn't think about this. But if you want to include new alternatives, you can try to develop a similar local priority function. So that could be possible as well.
Okay. Thank you very much.
You're welcome.